Okay. So, for example, zinc electrode. Okay. So, at anode, okay. So, metal ion electrode, these electrodes are reversible with respect to the electrode material. Here you can see these are reversible with respect to the electrode materials. And hydrogen electrode, zinc electrode is one example, hydrogen gas electrode. So, here also this is the primary standard electrode. So, here at anode, PT half H2 H plus. So the reaction is half H2 gas H plus plus electron. At cathode H plus class Raj class Raj class Raj class Raj. ଆପଣ ଆଜି ଦେଇ ଦିଅନ୍ତୁ। ହଁ ଦିଅନ୍ତୁ। Okay, so cathode, so the reaction is H plus plus electron half H2. Okay, so students, I just wanted to tell you that these electrodes, in this type 1 electrodes, the electrodes are reversible with respect to the electrode materials. So in hydrogen electrode, it is also called standard reference electrode, sorry, primary standard reference electrode. Okay, and the electrode potential is taken as 0. So cadmium amalgam electrode is also falling on this category.
Excuse me, ma'am.
Yes.
Ma'am, could you please scroll it a bit up? Type 1 electrode के पास.
Just a minute. I don't know why people are calling today. Again, sir. Again. ମୁଁ ଗୋଟେ କ୍ଲାସରେ ଅଛି 12:20 ସରିଲେ ମୁଁ କହିଦେବି। ଆଜ୍ଞା ଆଜ୍ଞା ଓ ବୁଝିଲି ଆଚ୍ଛା ଅଧାରେ ଆଜ୍ଞା 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 ସାର୍ ଆଜ୍ଞା ଆରେ I don't know what happened, it's not showing again. हाँ, is it okay Surajita?
Yes, ma'am.
I don't know what is happening to this. Okay, I'll send you the photo of this part. Okay, right now I'm sending. I think in the PPT it is there, type 1, type 2 and type 3, type 4. Is it there or not? In the PPT, it is there or not? Suprasad, Surajita,
Yes, ma'am.
it is there or not?
Ma'am, just a
Yes,
second.
ma'am. Yes, ma'am.
It is there. I'm sending you the photo because it is like I don't know what happened. The same part. Check in the group. Already sent. So this is about type 1 electrode. So you just remember one thing that these electrodes are reversible with respect to the electrode material. Okay? So next we'll discuss type 2 electrode. Please check your WhatsApp group. I think I have already, like you checked there, it is there already. Have you checked?
Yes, ma'am. Thank you, ma'am.
So type 2 electrode, these type of electrodes, these electrodes are of metal and insoluble So these electrodes are reversible with respect to the common anion. Example, calomel electrode. A simple diagram of calomel electrode. This is a schematic diagram. This is the platinum wire, which is a part of the electrode. Short download. Just do electron. So it is easy to write 2Hg, Hg liquid plus 2Cl minus equals Hg2Cl2 solid plus 2 electron. So this is at anode. So cathode, just opposite reaction, what happened at anode, that will occur at cathode. So cathode KCl Hg2Cl2 Hg liquid. Okay. So the reaction is Hg2Cl2 2 plus aqueous plus 2Cl minus. Okay, so this way for all the fuel cell and battery, you will just like remember the schematic diagram and the chemical reactions happening in that like fuel cell at cathode as well as at the anode. So similarly, at another one example of type 2 electrode is silver chloride electrode. Calomel electrode is also used as a secondary standard electrode, secondary reference electrode, and its electrode potential is 0.2422. So this is used as secondary reference electrode, and its electrode potential is 0.2422 volt. Okay, just remember that at 298 Kelvin. So silver chloride electrode is also like included in type 2 electrode. Here at anode, Ag shell, KCl. So the reaction is Ag will give you Ag plus electron. Just the reaction, what will happen at cathode, I think you can say me. You can answer this. What will be the reaction? Just opposite. What you have written at anode, that the same way you will just repeat the direction of writing that one, and the same thing you have to write at cathode. HCl. Okay. Is it okay? Then we'll discuss type 3 electrode. So type 2 electrodes are used as secondary reference electrode. Secondary in the sense that the potential of this electrode is established with respect to the primary reference, that is your standard hydrogen electrode, whose potential is arbitrarily assigned as 0. Okay? So if it is fine with you, then we'll go for type 3 electrode. Shall we discuss type 3? Am I audible?
Yes, ma'am, you are.
Yes, ma'am.
Yes, ma'am.
Sometimes you also respond. So these electrode, otherwise, because I am not able to see you all. I'm writing on the screen, so it's not possible to see you. Of a metal. One of its insoluble salt. Another insoluble salt. Salt carrying same anion.
Ma'am, one of its what is written soluble salt.
Insoluble salt. First one is insoluble salt. Then insoluble salt carrying same anion and a solution of a soluble salt carrying same cation. Okay. So these cations, these electrodes are reversible with respect to cation. Two cations. Okay. At anode, lead, which is a solid, lead oxalate. It is also a solid, and then calcium oxalate. So here the anions are same. Then calcium chloride, that is soluble. So this one here you can see these cations are same and here anions are same. Is it clear? So here the reactions are like this. Pb will oxidize to Pb2 plus. Plus 2 electron, then Pb2 plus C2O4 to minus So this is the reaction at anode. So the just opposite reaction will happen at cathode. So I think you can also write it. It is CaCl2, CaC2O4, PbC2O4, okay. So the reaction at cathode is just this part is first you will write PbC2O4 solid plus calcium 2 plus aqueous plus 2 electron. Okay. So next we will discuss type 4 electrodes. Up to this, any doubt?
मैम एक बार थोड़ा ऊपर कीजिएगा ना.
ये मतलब ठीक से दिखाई नहीं देगा तो यही है ठीक है.
Yes, ma'am.
So type 4 electrode, next one is systems such as SN4 plus, SN2 plus or H2Q and Q. Okay. So basically these electrodes are also called redox electrode. Just for example, at anode, the reaction will be PT H2Q Q. So here it will be hydroquinone. It is called hydroquinone. This is called hydroquinone. Quinone. So we can also write like this. Okay, at cathode, just the opposite way we have to write PTQ aqueous is to Q aqueous. It will be Q plus 2H plus 2 electron. Okay.
Ma'am, can you scroll up a little bit?
Yes.
Yes, ma'am.
Then reference electrode. Okay, so there are two types of reference electrode: primary reference electrode and secondary reference electrode. Okay, in primary reference electrode, standard hydrogen electrode. Okay, so the limitation with primary reference electrode, it is difficult in handling and readily poisoned by compounds like silver, arsenic, mercury, and sulfur. And it is also difficult to maintain the uniform 1 atmospheric pressure, and the concentration is 1 molar. Okay, so that's why secondary reference electrodes are good as compared to the primary reference electrode. And secondary reference electrode already we have discussed, that is your calomel electrode, silver chloride electrode. So next we'll discuss electrode potential. So what is electrode potential? So when a metal is dipped inside in its solution, so this is a metal which is dipped inside a solution. So in this case, when there are like three cases may arise. Case 1, solution pressure is higher than the osmotic pressure. So in such a case, the metal preferentially dissolved into the solution at the corresponding metal ion. So what will happen? So there is negative charge on the metal strip and positive charge from the solution. So there is, in this interface, there is a potential difference. Okay, there is a potential difference occurs, that is called electrode potential. So when solution pressure is greater than the osmotic pressure, the metal is dissolved out to the solution, leaving behind the negative ions on the metal strip. What will happen then? The negatively charged strip form an electrical double layer at the junction of the solution. So this is called the the potential difference occur or arises at the junction is called electrode potential. Is it clear?
Yes, ma'am.
And in the second case, when osmotic pressure is higher than the solution pressure, in this case, the metal ion preferentially get reduced. So it will reduce. So here it will be positive charge and negative charge from the solution. So this is your metal, this is your ions in the solution. Okay. So in this electrical double layer, So at this junction, the potential which arises, that is called electrode potential. But when solution pressure is equal to osmotic pressure, in such a case the electrode double layer is not formed and there develops no potential. Such an electrode is known as null electrode. Okay. Do you understand? Three cases arises when a metal strip is dipped inside its own solution, then solution pressure, if it is more than the osmotic pressure, then the electrical double layer occur, and the potential difference at the double layer is called electrode potential. Electrode potential. And when osmotic pressure is greater than the solution pressure, then also electrical double layer occurs, and there it is also called electrode potential. Okay. And you know, cell potential is equal to the electrode potential at cathode minus electrode potential at the anode. Okay, so next we will discuss measurement of cell potential.
Excuse me, ma'am.
Yes.
Now, what is written Mn plus ions in the?
So, array M, it is just a metal and solution. Just remember, okay. So this, just I'm telling you, when a metal strip is dipped inside its own solution, just it is M, and it is Mn plus solution means it is already dissolved out in the solution. Okay, are you getting?
Oh, yes, ma'am. Yes, ma'am. Its own solution.
Electrode potential of the cell is equal to electrode potential at cathode minus electrode potential at anode. Okay. How you will measure the cell potential? By a potentiometer. So that already you know, I think. Electrode measurement of cell's potential. So here A, B is a high resistance wire, okay. So here W is the working cell, whose EMF can be with adjustment of AB. Okay, so already I think in your 12th class in physics, already you know this one, how to like about the potentiometer. This is a circuit diagram of a typical potentiometer. So the calculation is ER. So EX, the unknown potential, can be measured by this way into ER. Is it okay?
Yes, ma'am.
Okay, so next we'll discuss Nernst equation. So let us consider a hypothetical cell reaction AA plus BB give you plus M. So this is the product, this is the reactant side. So if we apply Van 't Hoff's reaction isotherm, you know del G is equal to del G0 plus RT ln Q. Q is the reaction coefficient here. So again you know that minus NFE is equal to minus NFE0 because del G is equal to minus NFE plus TLN Okay, so if we divide by NF to each by with each terms, then you will get E is equal to E0 minus RT by NF plus RT by NF. So we can also write in this way E0 plus 2.303 RT by NF log okay. So at 298 Kelvin, R is equal to 8.314 Joule per Kelvin, and F is equal to 96,500 Coulomb, and T is equal to 298 Kelvin. So so if we put all these values now, E is equal to E0 plus 0.059 by N log Okay, so this is the Nernst equation, derivation of Nernst equation. Now we'll discuss application of Nernst equation. Then this chapter will be over. Okay. Okay. First of all, you please check whether you have any doubt for Nernst equation or not.
मैम आप पेन का वो थोड़ा मोटा कर सकती हैं, दिख नहीं रहा है।
हाँ,
ma'am,
मुझे
बहुत light
भी
दिख रहा
मुझे भी नहीं आ रहा है। ये एक्चुअली बड़ा कर देने से दिखेगा।
मैम वो पेन पे आप टैप कीजिए ना, वहाँ पे ऑप्शन आएगा।
ये यहाँ पे आ रहा है ऑप्शन, लेकिन सबसे मोटा वाला मैंने लिया है, फिर भी नहीं आ रहा है। ये बड़ा करने से हो जाएगा स्क्रीन। आप लिख लो, फिर मैं मतलब थोड़ा सा आगे पीछे करके आप लिख लो पहले, आफ्टर दैट नेक्स्ट में देखेंगे। ठीक है, पूरा स्टेप्स लिखो। ठीक है, पूरा स्टेप्स लिखो। जब दिख, हाँ ये दिख नहीं रहा, मुझे भी दिख रहा है। अभी दिखाई दे रहा ना?
थोड़ा थोड़ा दिख रहा है वैसे।
क्या थोड़ा दिख रहा है? आप कहाँ दिख रहे हो? अभी नहीं दिख रहा है?
दिख रहा है मैम।
हाँ तो थोड़ा क्यों, अच्छी तरह दिख रहा होगा। Completed. All of you please complete. Have you completed?
एक मिनट मैम।
ठीक है, करो।
Yes मैम।
Done. See, the मोटा वाला लेने से भी नहीं हो रहा है। ये क्या प्रॉब्लम क्या हो रहा है? If I'm choosing the thicker one, still it's not.
हम थोड़ा जूम आउट करके तब लिखने का ट्राई
हाँ
करते हैं।
हाँ तभी होगा, हाँ मैं वही बोले। Okay, so now we'll discuss application of Nernst equation. To find
Ma'am, what is the third point?
to find the EF of concentration cell, to find the solubility and solubility product. This one actually sometimes you will get some question, but this is not much important. But the most important part is to find the pH of an unknown aqueous solution. So this is very important. You will definitely get a question in your end semester. Okay. So I think 1, 2, 3, and 5 these points I'll teach. After that, this course will be, this topic will be over. Corrosion I have given the briefly discussed. On fuel cell battery also you will read yourself. Only this application I'll teach you. I don't think that we can discuss anything more because it is 12:19. You will have any more other classes after this. Do you have a class after this?
Yes, ma'am.
Yes, one maths.
Yes, ma'am. Okay, then you please join to that, and next class I'll teach you the application.
Ma'am, have you checked the quiz?
Yes,
Can you
because
share?
he has shared with me.